Hi, everybody. I'm Heike MacDonald, co-founder of Adventurous Systems, together with Professor Theo Dounas. First of all, I just want to thank you, Abel and CBC, for the invitation and for hosting this conference to explore digital trust in the built environment. As a team, we work at the intersection of AEC, digital twins, AI, and Web3. And the question we've been exploring is very simple. How should a real building be represented if we want to put it on a blockchain in a meaningful way? In this talk, How to Represent a Building on a Blockchain, I'll share the approach Theo and I have been developing, why the usual one NFT per building idea doesn't really work, and how a graph-based digital twin plus blockchain opens new possibilities for ownership, construction, and circularity. Just a little bit of background, brief background is a lot of work I'm going to show builds on earlier work that Theo with collaborators Professor Wassim Jabi and Professor Davide Lombardi published. The first paper looked at topology-generated non-fungible tokens, basically using blockchain as infrastructure for circular economy and architectural design. The second explored a non-fungible building component using smart contracts to support circularity in the built environment. In this presentation, we take these ideas a step further into a full graph-based digital twin plus tokenization pipeline that can be tested on real projects. So buildings don't fit blockchains. To explain the problem, let's start with how we already represent buildings. In BIM and IFC, we have very rich hierarchical models like walls, spaces, systems, all with geometry and metadata and clear relationships between them. Now contrast that with blockchains. Blockchains are fantastic at representing ownership as flat tokens, like this address owns this asset, but they are not designed to capture complex spatial topology. So when people say, let's put the building on chain as an NFT, there's an immediate mismatch. A building is not one NFT. It's really a graph of interconnected components, spaces, elements, systems, all linked in specific ways. If we flatten all of this into an NFT, or even just a simple list of assets, we lose the things that actually matter in practice. We lose where things are in relation to each other. We lose how they connect, like which space leads to which, how systems route through the building, and we lose how they change over time, like what was installed, replaced, or removed. So our starting point in this work is buildings are graphs and not JPEGs. And most blockchain tooling today ignores that. The rest of the talk is really about what happens when you take the idea seriously. From drawings to digital twins to graphs. On this slide, I just want to tell a short story about how we represent buildings, because that's really what this talk is about. If we go back to the Renaissance up to the 20th century, architects mostly worked with perspective and orthographic drawings. Those drawings didn't just show the building, they also framed how we design and control it, like plans, sections, elevations, all on paper. Then we moved into BIM and digital twins. Instead of static drawings, we now have dynamic data-driven models that can be linked to sensors and simulations. The model can know about energy performance, occupancy, maintenance. It becomes a kind of a living model of the building. Then we moved, what Theo and I are arguing is the next step in graphs. We start to treat buildings as relationships first, flows, adjacencies, dependencies, who or what connects to what. In that view, a digital twin is really a live graph of components and connections, not just a 3D object with data attached. And this matters for the rest of the talk, because to build digital trust, especially if we're bringing in blockchains, we first have to pick the right representation of the building. For us, that representation is a graph. Our implementation, the crypto twin, the end-to-end pipeline. So let's look at how we actually implement this idea of building as graphs on a blockchain. At a high level, the workflow is IFC, topologic, graph generation, Kuzu into Ethereum or smart contracts. We start with the IFC, the design file we all know. That's our source of truth for the building, the spaces, the elements, and the BIM metadata. Then we run it through topologic. This is where we do the spatial topology and graph generation, turning the BIM model into a network of nodes and relationships instead of just geometry. That graph is then stored in Kuzu, which is a high-performance graph database. Here we can run queries and analytics over the building, find paths, see what's adjacent to what, identify critical components, and so on. Finally, we connect this to a smart contract. We mint composable NFTs that correspond to parts of the building, to parts of the graph. So the blockchain becomes an ownership and integrity layer for the building twin. The important thing is that the pipeline preserved two kinds of structures: the spatial hierarchy, buildings, stories, spaces, components, and the topological connectivity, which are the adjacencies, boundaries, and openings. So we're not just putting a picture of a building on chain, we're putting a representation that still knows how the building is put together, how we represent a building on a blockchain. On this slide, I just want to quickly walk through the 4 stages of how we actually represent a building on a blockchain. Stage 1 is the IFC ingestion. We start from a normal IFC model and pass that with IFC OpenShell. At the point, we're not doing anything exotic. We're just extracting what's already there, the hierarchy, the geometry, the metadata, and the basic relationships between elements. This is our raw material. Stage 2 is the topological graph. Here we use topologic to turn the BIM model into a proper graph. Each node in the graph is an element, such as a wall, a space, a component, and each edge is a relationship, an adjacency, a boundary, an opening. This is where the building starts to look like a graph I've been talking about earlier. Stage 3 is the graph storage. We store that graph in Kuzu, a graph database. Elements become IFC element nodes, relationships become topological connection edges. And now we can actually run queries over the building, like find paths, look at centrality, explore circulation. All of the things that we had to do if you only have all of the things that are hard to do if you only had flat tokens. Stage 4 is the tokenization stage. Finally, we connect it to a smart contract. We mint hierarchical NFTs that mirror the structure of the building to story, to space, to component. And we keep adjacent information so lateral links aren't lost. Each on-chain ID points back into the Kuzu graph. So by the end of this pipeline, we haven't squashed the building into a single NFT. We've produced a graph-native digital twin where the blockchain is the trust and ownership layer sitting on top of the graph. Why we are building this platform. Up to now, I've talked about how we represent a building as a graph and link it to a blockchain. On this slide, I want to explain why that matters and the economic and governance terms. The core idea is in line at the top. When you turn buildings into queryable, verifiable networks, you unlock new types of markets and contracts. First, compositional ownership. Because building is a graph, we don't have to think of ownership as all or nothing. We can let people own specific systems or levels. For example, all the HVAC units across a portfolio, just the ground floor of a mixed-use building, or a set of modular components that can move between projects. The representation supports that because the pieces are explicit nodes in the graph. Second, verifiable construction. During construction, contractors can update the tokens as work is completed. That gives us an on-chain time-stamped record of what actually was built compared to what was designed. So instead of arguing over PDFs and email threads, we have a shared source of truth tied back to the digital twin. Third, automated performance payments. Once a building is operating, we can connect sensor data to those same graph elements. Smart contracts only release payment when the data shows that performance targets are met. For example, HVAC efficiency, comfort metrics, or energy savings. So this isn't blockchain just for the sake of it. It's using a graph native representation to enable new ownership structures, better accountability in construction, and programmable contracts around performance. On the previous slide, I talked about ownership, construction, and performance. Here are three more areas where a graph native tokenized building really starts to matter in day-to-day operations. Number four. Number four is simply a chain transparency and circularity. Imagine materials arriving on site with NFTs attached, not as speculation, but as passports, as in material passports that can carry provenance and usage history. Because those tokens are linked into the building graph, we always know where the component ended up. And when it's removed, we can route it back into a verified market for reuse rather than landfill. Number five, predictive maintenance and dynamic insurance. Once the building is represented as a graph, we can run graph neural networks over it to learn failure patterns, which combinations of elements and conditions tend to break. Insurers and operators can then price risk on how critical a component is in the topology and not just on its replacement cost. So a highly connected node is treated as is treated very differently from an isolated node. And number six is design as a service. If you're an architect or engineer, you can treat successful building layouts as proven topologies and license them as reusable templates. New projects can be automatically checked against these approved graphs, so you can get a blend of creativity and validated patterns. So across all six use cases, the shift is the same. We move from static assets to programmable, composable building graphs with trusted histories. Limits, trade-offs, and open questions. Before I wrap up, I want to be very clear that this isn't a magic bullet. There are real limits and trade-offs in what we're proposing. On the technical side, the first issue is gas and scale. If you try and put a full building graph directly on chain, it very quickly becomes expensive. So we're looking at batching, compressing, and realistically at layer twos or app chain solutions rather than mainnet-only deployments. The second technical point is that this almost certainly has to be a hybrid model. The blockchain is great for identity, integrity, and key events. Who owns what changed when? But the heavy lifting for data and queries has to live on graph databases and CDEs like Kuzu or IPFS backstores, where you can actually run complex analysis to scale. Then there's research and governance questions, which I think is really interesting for this community. Like, how do we align this with existing IFC, digital twin, and logbook standards so we are not inventing yet another silent system? Who is actually allowed to mint, update, or revoke these component tokens in practice? The contractor, the facility manager, or the regulator? And how do we handle disputes and multi-stakeholder governance over the twin when many parties have legitimate interests? So we see the work as an earlier step. It shows that graph native tokenized buildings are feasible, but there are still a lot to do together around standards, governance, and scaling. From IFC upload to minted building graph, I'll just show a couple of screenshots of our platform. I don't think there's sufficient time for a full demo, but just as a quick little showcase here, So as you saw earlier, slides I've showed the architecture. Here I want to show a little bit more of it feels like for the user using our prototype. So step one, you would upload your IFC file to the Streamlit web UI, and upload from any BIM tool, or just upload the file. There's no special modeling, no new format, just the file they already have. Step two would be generating the graph. With one click, we run through TopoloGic, which turns the IFC file into a topological graph. It's, as I described earlier, nodes for spaces and components, edges for relationships. Step three is store and analyze in Kuzu. That graph is then stored in Kuzu, so we can query it as in find paths, inspect connectivity, run analysis on circulation and critical elements. Step four is visualize. We render the graph back in the browser as a 3D view in the building of the building connectivity, so you can literally see how the spaces and components are linked. Step five would be the mint and tokenization. And when you're happy, you hit the mint. You hit mint. The system creates a composable building graph NFT via a smart contract with on-chain IDs pointing back to the graph. So from the user perspective, it's just upload a model, see a graph, click mint, and underneath that, you get a building that is now verifiable, tokenized graph. To wrap up, we've shown that it's technically feasible to build a graph-native digital twin pipeline and blockchain integration. The next step for us isn't more theory, it's real projects. So we're now looking for projects and partners to test this with. Real IFC models and live construction workflows, so we can plug into what they've already been doing on projects. Experiments in compositional ownership and performance-linked payments, where parts of the building and the behavior actually matter for how value flows. And circular material pilots and supply chain traceability, where components carry provenance and can move between buildings and a verified history. So if you have a building and a problem around trust and traceability, we'd love to talk and try this out together. You can find us at adventurous.systems, and you can check out our prototype at GitHub at Adventurous Systems Crypto 2-in-1. Thank you very much for your time. And just before I close off, I would just like to say I would like to apologize beforehand that I'm not able to make the discussion as I have other engagement. I'm sure Theo will be able to answer any questions you may have. Thank you very much for your time.